Hello and welcome to experiment number 5 in Electrotech 1100 and Electrotech 1102. Today we will be looking at the series parallel circuit in figure 5.8 of experiment number 5. We will show you how the circuit was built and how some of the measurements were taken. And at the very end, the last slide shows you table 5.2 all filled out with all the measurements that we took during the lab. In the procedure, step 1 says use the coded values of the resistors and calculate the total resistance and the voltage and the current of each resistor in the circuit shown in figure 5.5, which is the circuit that we built. This is an exercise that is left for the students to do on their own. It's really good practice for this course to be able to analyze this circuit. I will tell you though that the calculated total current should be 13.3 milliamps. The total resistance that you should calculate is 1,801 ohms. And the voltage drop across resistor 1 should be 7.5 volts. If your calculations do not match with the numbers that I just mentioned, that means that you have done something incorrect and you should go back and check your analysis. In step 2, you're asked to measure the actual resistance of the resistors and record your values in table 5.2. So this is very straightforward. The resistors are not connected to the circuit at this point. You can see the connections for resistor 1 and resistor 2, and you can see the readings here on the on this slide. For R1, we measured 740 ohms. And for R2, we've measured 1,280 ohms. Likewise, R3, we measure the value of 1,290 ohms. And for R4, we measure the value of 2,500 ohms. For R5, you can see that we have selected the R times 100 scale. And the reading here is 9.9. So that gives us a value of 990 for R5. And for R6, you can see right here, we have selected the times 1K scale. And the reading on the meter is 3.6. So that gives us a resistor reading of 3,600 ohms. In step 3, we're asked to connect the series parallel circuit shown, but don't connect the power supply. And then in step 4, we're asked to measure the total resistance. So here is the circuit built. Notice the layout of the resistors. Notice the layout of the resistors on the board. They are laid out in the same way that they are laid out in the circuit diagram shown in experiment 5. This is resistor 1. This is resistor 2. This is resistor 3. This is resistor 4, this is resistor 5, and this is resistor 6. And notice the ohm meter is connected up to measure the total resistance. So we put the 2 leads for the ohm meter where the voltage source would be connected in order to figure out the total resistance. And zooming in on the meter to actually read the resistance, what we get here is a reading of 2.3 where the needle sits, and it's 2.3 where the needle sits right here, and the scale is times 1K, so that gives us a total resistance reading of 2,300 ohms. Okay, for step 5, we're asked to connect the power supply to the circuit, which we've done here, and set up the voltmeter so that it can measure VT. So what we've done is we've taken the positive and the negative leads from the power source, and we've connected it to the positive terminal of R1 and to the negative terminal of R3 and R4 right here. R3 and R4 are connected up in parallel, so the negative terminal is right here. Likewise, to measure the voltage, you connect up your voltmeter in the exact same place that you've connected up your power source. And then you adjust your voltage till you get a reading of 24 volts on your voltmeter. So you can see right here with the meter on the 25 scale, that means we're reading off the bottom here, 25, and we adjusted the voltage until we got a reading of 24 on the voltmeter. Okay, for step 7, you are asked to measure all the voltages and record the results in table 5.2. So what we're going to do is show you some pictures of how we recorded 2 different voltages. We'll give you those readings and then we'll give you the rest of them rather than make you sit down and watch pictures of voltmeters hooked up. It's pretty straightforward stuff. So here we are measuring the voltage drop across resistor 1, and you can see, I don't know how you can see, how easy it is to see, but these are the leads right here that came from the voltmeter. And if you follow, this is the positive lead right here. If you follow it all the way over, it's connected up to the positive terminal of resistor 1. And if you follow the black lead from the negative terminal of the voltmeter, it comes all the way up here to the negative terminal of resistor 1. So with the power turned on, you basically just connect up your voltmeter leads right across resistor 1, and that will give you the voltage drop across resistor 1. So if we look at, this is what the meter actually looks like in this case. It's hard to see, a little bit of glare there, but it is on the 10 scale. So the top reading right here is where you're reading off the top scale, because this is 10 right here. And what we actually measure for this instance is a voltage of 8.2 volts for resistor 1. The next resistance measurement that we're going to show you is the measurement for resistor 6. And again, this is pretty straightforward. Resistor 6 is this resistor right here on the far right hand side. We have the positive terminal of our voltmeter connected up right here to the positive terminal of resistor 6. Now remember, the positive terminal for a resistor is where the current enters that resistor, and the negative lead from the voltmeter is connected up right here to the negative terminal of resistor 6. So with the circuit powered up, you basically leave your circuit as it is and just connect your voltage, your leads from the voltmeter right across the resistance that you want to measure the voltage for. So if we zoom in on the actual voltmeter here, we're on the 25 scale. So that means we're on the bottom here, 25 scale. And our measured voltage in this case is going to be 12.2 volts. The other voltages that we measured, which we won't show you the circuits for because it's pretty straightforward. Resistance 2, we measured a voltage of 9.0 volts. Resistor 3, 6.3 volts. Resistor 4, 6.3 volts, which they should be the same because those two resistors are in parallel. Resistor 5, 2.9 volts, and resistor 6, which we just showed you, it's 12.2 volts. And that brings us to step number 8. Step number 8 says measure all the currents and record the results in table 5.2. And again, we're not going to show you all the current measurements, but we will show you enough to give you an idea of how it was done in this case for all of them. So what we're looking at now is the circuit connected to measure the total current, IT. So let me pull up my pointer. If you can notice right here, the circuit is broken between this point and this point. That is between the negative terminal on R1 and the positive terminal on R2 and the positive terminal in R5, which are connected together. So you can see we have this connection between the positive terminal of R5 and the positive terminal of R2 right here. Without the ammeter in place, there would have been a connection right here. But we're trying to measure the total current, and if you look at the circuit diagram, the total current is the same as the current through resistor 1, because R1 is in R1 is in series with our voltage source. So if you measure the current through R1, that will give you the total current. So we break the circuit, and that's how you have to do it to insert an ammeter. You break the circuit here between R1 and whatever R1 is connected to, which is this right here. And now we connect the positive terminal of our ammeter right here, because the current flows from here into the ammeter, and then it comes out of the ammeter and connects back up to the other point in the circuit that we disconnected from. So that is how the ammeter was connected to measure the total current, which is also the same as the current through resistor 1. So if we zoom in and actually have a look at what's going on here, you can see we're on the 25 scale. So the 25 scale is the scale on the very bottom here. And what we actually measured here was a current of 12.7 milliamps. So 12.7 milliamps is the current for this, for total current and for the current through resistor 1. Next, we show the setup for how to record or how to measure the current through resistor 3. Resistor 3 is this resistor right here. Now notice, normally without the ammeter connected up, this blue piece of wire would be connected between here and here. So basically the top of R3, the positive terminal on R3 gets connected to the bottom of R2. This is R2 right here. And this is the negative terminal of R2. Current comes in through the positive terminal, which is here, exits the minus terminal. So normally you'd have this blue piece of wire connected here on the negative terminal of R2, and then the other end where it's still connected and the positive terminal of R3. So basically what we're doing in this situation is we're breaking the circuit at R3. It doesn't matter which end of R3 you break. You could break the circuit right here on the top of R3 where we have chosen to break it, or you could break it on the bottom where we have not chosen to break it. Doesn't matter, but basically you break the connection to R3, which we've done, and then you place your meter leads on the 2 points of the circuit where the connection was broken. So right here we have the positive terminal, the positive lead from the ammeter is right here. So the current flows down through, flows into the ammeter, comes back out of the ammeter through the negative lead, this black one right here, and that connects up to the positive terminal of R3. So without the ammeter in place, the current would have flown from here to here through a piece of blue wire. But instead of making it flow through a piece of blue wire, we're going to force it to flow through the milliammeter and then back to where it should have flown. Where it should have flowed. And when you zoom in on the meter and read it, you can see we're on the 10 scale, which means we're reading off the top set of numbers here. And when you're trying to read I3 in this situation, what you get is 5.5 milliamps. So 5.5 milliamps is what this reading is. The final reading that we're going to show you in this lab is the current through resistor R6. And this is resistor R6 right here. And notice that we had to break the circuit at the bottom or the top of R6. The circuit was not broken at the top of R6 because you can still see the connection here between R5 and R6. R5 and R6 are in series, of course, right here. So we broke the connection at the bottom of R6. Normally, without the ammeter in place, there would be a piece of wire between here and here. And that piece of wire is still shown here. It says yellow piece of wire. But the yellow piece of wire is only connected to this end at the moment. It's connected right here to the bottom of resistor R4. And the other end, you can see a little piece of the black. You can see all these leads have black plastic coating on the ends of them, and you can just see a little bit of the black plastic coating right there for this end of the yellow lead. So this yellow lead this end is not connected to anything. It's just lying on the board, but it's covered up by this red alligator clip. So we break the connection in the circuit between R6. At the bottom of R6, and the bottom of our 4. Bottom of our 6, bottom of our 4. We break the connection and then we insert the meter. The current comes down through here, and then we force the current to go through the meter. So we put the positive lead right here where the current enters the meter right here, and then the current exits the meter and goes back to the other end of the connection where we had broken the circuit. You also could have connected this black lead right onto this clip, the other end of the yellow lead right here. That would work fine as well. Either or works. So here's our zoom in on the meter for I6. Notice we are on the 5 scale, which means we're reading off the middle set of numbers, the one that ends in 5 right there. And looking at the scale and what we can see from there, we're going to say that the current in this case is 3.9 milliamps. All right, so those are all the readings that we're going to demonstrate for you at this point. You can see here is table 5.2 filled out completely with all the measurements that we did for this lab. You also notice a couple of readings in table 5.1. Those should match up with your own calculations. Table 5.1, you guys have to do your own calculations and fill this in. There are a couple of sample ones filled in. If your calculations aren't matching up with what's already filled in table 5.1, you have to double check what you're doing. But all the measurements are for you right here. That's it, and I hope you enjoyed this short video on experiment number 5.